Okay, welcome to Lab 7. In Lab 7, we're going to learn about the displaying using your 8051 IC. So in displaying, what we're going to use is this 7-segment display. So they call it as a 7-segment because they total have a 7 segment. The segment A, B, C, D, E, F, and G. So there's a 7 segment. So if you notice, each segment is actually a LED. So there's a LED in every segment. So you need to give a 5 volt to the positive side of LED, then a 0 volt or ground to your negative side of the LED. Then it will light on. So VCC and ground, then they will light on. So in commons, there's two types of 7-segment display, which is the common cathode and also the common anode. So if you look at the circuit, why they call it as common cathode is because if it's common cathode, all of the ground are connected to each other. If you look at the circuitry, you can see the ground pin are connected to each other. So all the ground of the 7-segment display are connected to the same pin, right? And every 7-segment, they have a 2 ground pin, but actually they are connected to each other. You can connect 1 ground pin, then that's enough. You connect this one means both sides are connected to the ground, because they are connected to each other. Then for common anode, their VCC are connected to each other. Their positive side are connected to each other. So means if you draw the circuitry, so if this is a common cathode, then their ground pin are connected to each other. You need to connect the ground pin to ground, then it should work. Then for common anode, their positive side are connected to each other. So their positive side should connect to VCC, which is the 5 volt. If you are using your 8051 to light on, then you can use your port to light on all the segments. So let's say I connect this one to port 2 bit 0, this one to port 2 bit 1, and this one to port 2 bit 2, right? So let's say I want to light on this segment. The other side are already connected to ground on my 8051. So the other side, this one, if I want to light on this segment, I must give a logic 1, which is a 5 volt. Then this segment will light on. So this one, if I don't want to light on, I give a 0, then it will be 0 volt, which is ground. Then both sides are ground. Then this segment will not light on. Right? So if this one the lights on, then I need to give a 1 here. So that this side is a 5 volt, the other side is ground, then this one will light on. So this is how you control the 7-segment display by using your 8051. So the one we're going to use in the lab is the common cathode LED. So if you common anode is the inverse. You connect this one to VCC, then you connect this one to your port 20, port 21, and port 22. So that's why let's say I want to light on this one, then I must give a 0 here. So that this side is 5 volt, this side is ground. Then it will light on this segment. So there's a reverse connections, then there's a reverse controlling. If I want to light on for common anode, I must give a 0. I want to light on for common cathode, I must give a 1. Okay. Then here is example of displaying the number from 0 up to 9 by lighting on each of the segment accordingly. Then this is the connection. If you're using your 8051 to control, you need the 7 pins. Or else you can use another one, is called another IC is called BCD to 7-segment decoder. So if you're using this IC, you just need 4 pin only. What you need to give is giving the BCD coding to your 7447 IC, then they will give you and convert it to a 7-pin output to light on the 7-segment display for you. And this is the truth tables for the 74LS47. For example, if you want to light on display number 0, you just give low to your 4 pins of that 7447, this 4 pin. Okay, then they will convert it for you, the ABCDEFG segment, to display the 0, all on except segment G, right? All will be on except the segment G, the middle one here didn't on, right? So in this lab, we are going to use this code together with the circuitry here. So what this lab going to do is, by using the switches, there's a 4 pin connected here, okay, this 4 pin, to control the display number in this 7 segment. Okay, so we need total 4 pin because we want to display from 0 up to F, the hexa numbers. So you need 0, 0, 0 up to 1, 1, 1, 1. So that's why they're using 4 inputs to help you displaying the digit 0 up to F. So here's the code. The same thing, start with a 0, 0 main, right? Then they put your port 1 as a output, port 2 as an input. Then the next one is they move something in a pointer register. DPTR is one of the register which is used as a pointer. They are just a register only to store values which is you can use as a pointer. After this, so they set a number set, means they are going to get these locations, okay, this first locations, where is this value stored. So this is basically a dB, mean a data byte. You are defining a data byte in your program, then you store this number in a certain location in your memory. Okay, you store the number, let's say 3F, 06, 5B inside your memory, okay, by doing the db command. So they will store this number inside memory. Then I need to know where I store this, so I have the label here, set SEG. So that's why the SEG maybe this location in your memory is a number, location number 8. So SEG is basically represent this number 8. So that's why I'm moving number 8, the location where this 3F store in your memory, the memory location 08, into the pointer dptr. So at the end, your dptr will equals to 08 instead of 3F. They will equal to the memory locations number. Okay. After that, you are moving your P2 to your A, right? You are moving your P2 to your A. So what is P2? Your P2 is basically the switches input. Okay, here is your P2. But we're only using 4 pins only. The other 4, from 4 up to 7, we didn't use. We only used 0 up to 3 only, right? Because there's only connections for 0 up to 3. For 4 up to 7, there's nothing here. So that's why to avoid the confusion, if you didn't connect anything, the input, the values in the register may be floating. It can be 0, it can be 1. So to avoid that thing to be happen, they do something is called this one, mask out the upper nibbles. So that's your P2 register. You have a 0, 1, 2, 3, 4, 5, 6, and 7. Okay, 0 up to 7 bit. Then the thing you have is only the lower 4 bits. The upper 4 bit is connecting nothing. Okay, so let's say your bottom 4 bit is connected, is all giving a 1. Then the upper 4 bit we don't know what is the value because there's nothing connected. So that's why to mask out all this bit, that using this A and L means the logical AND. So that's why the AND bit is 0, 0, 0, 0, 1, 1, 1, 1. This is a 0F, the number 0F here, the AND with 0F. So when you do an AND operation with 0, all the thing will become 0. I don't care what is this, because I AND with 0, then the value becomes 0. Okay, then if I AND with 1, then they will follow the values here. So I'll get back the values in this P2 register. Okay, so let's say P2 register here is 1001. If I AND with 111, I will get 1001 here. So that's why I will get back what are the values in the lower 4 bit of my P2, and at the same time I make the upper 4 bit become all 0. So this is the way they filter out the bits which I don't want. Okay, they filter out the upper 4 bits which you don't want by using the logical AND. So after they've filter out the bits they don't want, the next step is they want to move the values from somewhere of your memory to the register A. So what they do is they're using the DPTR to plus with your A, right? So just now you have filter out the values you want in your A. So let's say now my switches, okay, I'm using my switches to control something. So let's say Now I want to display values 2, right? I need to give 0, 0, 1, 0 from my switches. So that's why if I didn't, if you still remember the switches functions, if I on the switches, if I connect to ground, then I will get 0. If I off the switches, I will connect to 5 volt to VCC here, right? Then I give a 1. So I will on this one, off this one, then on this one. So I will get a 0, 0, 1, go into my P2 0 up to P2 3. Right? So when I move my P2 into A, then I will have a 0, 0, 1, 0 in my P2, then the upper part is don't care. So after I end it, my A will equals to 0, 0, 0, 0, 0, 0, 1, 0, which is a 0, 2 in hexa. Right? Then I will using my DPTR. So let's say my DPTR is a 08 just now, right? So my DPTR was 08 plus with this number, which is 2, is equal to 10, right? 8 plus 2 equals 10. So this is 08, 09, then this location is 10. So I'm going to take these values 5B. This command is mean I will go to this location of your memory and take the values there, which is 5B, and put into your A. So after this coding, my A will become 5B. Then I will move into my P1. So why they move 5B into P1? Okay, so if you look at the 5B and look at the connections here, so let's say it's 5B, yeah? Just now 5B is equal to 0, 1, 0, 1, right? This is 5. Then B is AB is 11. 11 means it's 1, 0, 1, 1. Okay? So this is 5B, right? So your 7 will be P1, 7 will be 0, 1, 0, 1, 1, 0, 1, 1. So at the end, this segment, this one cannot see. I need to using this one will be better. So your bit 0 up to bit 7 is 5B, just now is 0, 1, 0, 1, 1, 0, 1, 1, right? So your bit 0 is 1, so your segment A will lights on. Your bit 1 is 1 also, so your B is lights on. Then bit, because 0 up to 6 is connected to A, B, C, D up to G here. Okay, so then P2 is a 0, so C will be off, so your C is off. Okay, then your P3 is 1 again, P2 3 is 1 again, so your D is on. Then your P2 4 is 1 also, so your ABCDE is on. P2 5 is off, so your F is off. P2 6 is on, which is your G. So that's why you display a number 2 here, right? So this is how you display the digits 2 by using the command. So it's the same as what you want in your switches. Remember, just now if I want to display 2, I shift it into 0, 0, 1, 0, which is 2 here by using the switches. Then from the coding, I will go to the locations here to get the 5B. Then the 5B actually displaying the number 2 for you. Right? Then after do that, you jump, go to start again, and you keep on moving the values from you go to 2 again to keep on getting the, go to start to keep on getting the values from your P2 and display it out. So basically this code is doing the displaying by using your P2 input to display the values you want in the 7-segment display. Okay, so in this lab summation, you just need to build up this circuitry, then to take a short video to explain what is actually happening, and is to show your output is of a 7-segment display is following the switches. Then that's enough. Okay, So for this lab, you just need to build the circuitry using the programs, then showing that your output 7-segment display is displaying the digits according to the switches. If you put all on, so all becomes 0, 0, 0, then it should display 0 at your 7-segment display. Okay, so I think that's all for your lab 7.